Okay, so the first video apparently somehow got set as private and the sound isn't working. So I'm gonna re-record it with the old one playing in the background. So hopefully I'll get the timing right. This is Unit 8, Lesson 1. There's only 2 lessons in this unit because usually we do this whole teach the class thing and it's the last thing we do for the year. So we're gonna look at how to solve problems using formulas. You're not required to memorize, any of these formulas. They'll be given to you on a formula sheet. There's just no need for that. So the main thing is just understanding what all of the letters stand for within a formula. And so what I mean by that is knowing, for example, that I'm just going to kind of fast forward here a little bit. B is for base, H is for height, the D's stand for diagonals, so that's like crossways in a shape. B's stand for the bases of a triangle or a trapezoid. Then you have capital letters, and we deal a lot with those in 3-dimensional shapes. So like capital P is perimeter. Area of a regular polygon can be perimeter times apothem or A times S times N, which your perimeter is the length of a side times the number of sides when you're dealing with regular shapes. So S standing for side length, N standing for the number of sides. Okay, so just again, understanding what all of those mean when you're utilizing those formulas so that you can plug things into the right spot. And so the area of an object is the amount of space that is inside of it. And the perimeter of an object is the distance around an object. And so 1 is 2-dimensional while 1 is 3. In a circle, it's the same, but we call the perimeter the circumference, but it is the distance around the outside of a circle. All right, so since area is 2-dimensional, you're looking at that space inside. So like this is a rectangle. So its area is base times height, and its perimeter is adding up all 4 sides. So base times height for this will be 3 by, is that 6? Oh, 5, sorry. So 15 units squared. Labels are important because area is 2-dimensional, so it's squared, and perimeter is linear, so it's not. Perimeter of a rectangle is 2L times 2W, but you could also just add up all 4 sides. So we have 2 times 5 plus 2 times 3. So 10 plus 6 is 16. And again, that's units, but not squared. All right, so finding perimeter and area, you're going to utilize those formulas. And so like area of a square is base times height. But we don't have either of those dimensions. This is a square, so you can use the fact that it's an isosceles triangle and it's a 45, 45, 90. And you can use that relationship if you remember the rules. Or you can use Pythagorean theorem and solve for it. It doesn't matter. But you can section that off and look at the right triangles, which is why we always do right triangles before this unit. So we're just going to use Pythagorean theorem to solve because not everybody has their 45, 45, 90s figured out. So a squared plus b squared equals c squared. So we plug in x squared plus x squared is equal to 4 root 2 squared. Just type that in your calculator, but really you're squaring the 4 and squaring the root 2. So we get 2x squared when we combine like terms. The 4 gets squared at 16, root 2 squared is 2, so you get your 32. Divide over the 2 and then square root both sides. So those are both 4. which, again, if you remember that leg times the square root of 2 is the ratio for 45, 45, 90 triangle. So base times height for your area is 4 times 4 because it's a square, so 16 units squared. And we'll do area of a parallelogram before we come back and do perimeter. Really just because I forgot to do perimeter, but base times height. Make sure you use the true height. The true height will always form a 90-degree angle with the base. So 17 times 30, so 510 units squared. That 20 is used for perimeter, but not for area. The perimeter of your square is 4 times the number of sides, so 4 times 4. So it's also 16. That is not always the case, but it does happen with this one. Units, not units squared. Perimeter of a parallelogram, you're just going to add up all 4 sides. Just like a rectangle, since opposite sides are equal, you can do 2 times L plus 2 times W, or 2 times one side plus 2 times the other, doesn't matter. So using the 20 and 30 here, we get 60 plus 40, so 100. And again, we're going to use units because it doesn't have a label. All right, so trapezoids are a bit different because if you look at the formula, you have 1/2 times the height times B1 plus B2. And your bases, your B1 and B2 are the parallel sides. It doesn't matter which is which. Your height will, again, always form that 90-degree angle with the base. So the height in this case is 4. So we have enough for our area because we have B1, B2, and we have H. So we can calculate the area just fine. That opposite side, though, is not 4. And in order to find perimeter, we will have to calculate it. So we'll do that in a second. Go ahead and plug everything in to find area. So 1/2 times 8. Sorry, times height. So 1/2 times 4 times 8 plus 6. 1/2 times 4 is 2. 8 plus 6 is 14. So 28 feet squared is your area. Okay, so again, to find perimeter, we need the length all the way around. So we have to find that last diagonal that's not labeled. So again, height forms that 90-degree angle. We've now just created a rectangle inside of our trapezoid. So really, area of a trapezoid is the area of a rectangle plus the area of a triangle. So because of that, that little length right there is 6. And so that little distance right there will be 2 because 2 plus 6 is 8. So the height is 4. And we now have this triangle with a height of 4 and a base of 2. And because it's a right triangle, we can find the missing side. So we use Pythagorean theorem a lot in this unit. So a squared plus b squared equals c squared. So 2 squared plus 4 squared equals c squared. So we get 4 plus 16, which is 20. And we're going to simplify that radical. So that's the square root of 4 times 5. And 4 square rooted is 2, so 2 root 5 is your C. It's also the last side of that trapezoid. So we add all of the sides together. So we get 8 plus 4 plus 6, it doesn't matter what order, plus 2 root 5. Without a decimal approximation, we can only add our like terms. So we get 18 plus 2 root 5, and that is your perimeter. And that would be feet. I forgot my label. So you can type that in your calculator and get a decimal approximation, 22.47 feet. I skipped ahead a little farther. Okay, on this one, this is isosceles, so we don't have to find the other side. That's automatically 5. But in order to find area, we're going to have to find the height. So it's easier to find perimeter here first because you can just add up all the sides. 5 plus 14 plus 5 plus 20. So 10, 30, 44. and that's units. Again, we don't have a label, so always put units on there. This one we're going to do like we did on the other one, but we're going to find height instead of the missing side. So you create that rectangle in there. So that's 14. Take the 20 minus 14, and we have 6 left, but that needs to divide evenly between those two sides, so 3 and 3. If you remember your triples, then this is a 3, 4, 5 triangle, and there's no reason to do Pythagorean theorem. But otherwise, you'll need to do the same thing we did over here and do Pythagorean theorem. Okay, so then we can plug everything into your area formula. 4 is the height, 20 is the base, and 14 is the base. We will not use the 5 in our area formula. We used it in perimeter, and we used it to help us find height. That's all we use it for. So 2 times 34 is 68, and that is units squared. All right, shaded regions are composite figures, so you're either adding areas of different shapes together or you are subtracting them, depending on, do you have like a hole in your shape or is it shapes on top of shapes? And so for this first one, we have a triangle and we have a rectangle. So base times height and 1/2 base times height are our formulas. Always start by writing down your formula. And so for the rectangle, we're just going to calculate that. So, and for the triangle, excuse me. So 1/2 times 12 times 3, and then add 12 times 5 for the area of the rectangle. So 18 plus 60 is 78. Again, no units. So that should say units squared. I forgot my label on that one. Where like that one we're adding, this one we're subtracting because we just want that yellow region. And so the triangle is really like cut out of the square. And so we're going to take the area of the square. So area of a square is, and then is side length squared, or base times height, same thing, minus area of the triangle, which is 1/2 base times height. And we have everything we need, so we just plug those in there. So we have 12 squared minus 1/2 times 12 times 4. So 144 minus 6 times 4 is 24. So 120 units squared. All right, circles again are the same concept. You're using a formula, you're plugging in, and you're solving. If it says leave in terms of pi, you're going to leave the pi symbol on the shape. With circumference, you have two different formulas. You have 2 pi r, or you have pi times diameter. If they give you radius, then use the formula that has radius in it. So 2 times pi times 3. Leave in terms of pi means we leave that symbol just as it is. So the circumference here is just 6 pi. And that would be units or feet or centimeters or whatever the label is. Radius, given area, we're just working backwards. But same thing, write down your formula, plug in what you have, and solve for what you don't. So this time we have the area, so we plug that in for A. So we have 25 pi is equal to pi times r squared. And then we solve. So the pi's we divide off and they cancel out. And so r squared is equal to 25. So r equals 5. A sector is like a slice of the circle, so like a slice of pie. What is the area of that? The formula, again, you can see on the first page, is theta over 360 times pi r squared. So it's a fraction of the area of your circle. And so it's a ratio, that theta being the central angle, so the 70. 70 out of 360 is like the ratio of the circle that you're taking, because remember there's 360 degrees in every circle. And so your 70 here is your theta. So we do 70 over 360 times pi times 8, your radius squared. Leaving in terms of pi, you're just going to essentially take 8 squared times 70 in your calculator and then reduce that over 360, and you're going to get a fraction, and that's fine. But if it says leave in terms of pi, then don't get a decimal value, even if you have them in the front as well. So we have this really big fraction. That's fine. That's going to be your answer unless it asks for an approximation. Same thing, area of a shaded region, just now looking at circles. We have a gap here, so we're going to subtract. We're going to take the area of that rectangle minus the area of the circles. The key thing here is to understand that you have area base times height minus 2 pi r squared, that the radius is the same no matter where you're looking at it in a circle. So we can just keep drawing radii all the way across, and they're all the same length. Same up and down, that would be 6. This is also 6. So the height up and down is 12. So that gives you your dimensions when it's inscribed in a rectangle or a square. That gives you your dimensions in of that rectangle because it touches edge to edge. All right, so you can just plug those values in now that you know them and then solve them out. Okay, so I'm going to use 3.14 for pi just because we haven't done that yet. You can type this whole thing into your calculator all at once as long as you're careful with parentheses and where everything goes. On this next one, we're finding the distance around the figure. So if you think about it, this here and this over here form a circle. So we really need the distance around that circle, which is circumference. And then we need like half of the distance around the square. We only really need 2 of the sides instead of all 4 because we want the outside of the shape. So half of the perimeter, which if you distribute that half, you're really just adding the length, 1 length and 1 width, or 2 L's if you want to just take off the widths. However you want to do it. It's a square, so they're all the same. So you have 2 pi r, which actually you're given the diameter here, so let's use pi times diameter. Funny how I make the same mistakes both times. And then you can just plug everything in. Diameter is 8, length is 8, width is 8, everything's 8. So 3.14 times 8 plus 8 plus 8. Type that in your calculator. Again, getting an approximation because we're using 3.14 for pi. And that is labeled centimeters, and it's linear, so just centimeters. Area of a regular polygon is probably the hardest one just because it takes so many steps. Remember that a regular polygon is a shape that is both equilateral and equiangular. To find the area of a regular polygon, you're still going to use a formula. P is equal to the perimeter, and A is what we call the apothem, which is the distance from the center to the midpoint of a side. And so that line shown on this picture here, that is your apothem. And you can draw that to any midpoint, but it splits that side in half, and it always forms a right angle. And so you have the perimeter of your regular polygon, which is the side length times the number of sides, and you have your apothem. So you can rewrite this as 1/2 A times S times N. That tends to be how I solve them out, unless you're explicitly told the perimeter is this. And then it's easy just to plug that in. So finding the area of a regular polygon, again, I always start by just writing down what I have in terms of my formula. So this is a pentagon, so I know it has 5 sides. The apothem is 5.8, and the side length is 8. So I have an A, I have an S, and I have an N. These are the nice ones because you can just plug all of those into your formula and solve them. So it is important, though, that you know what shapes have how many sides. So pentagon 5, hexagon 6, heptagon 7. We have talked about those before. So you just plug everything in, type all that in your calculator. Oops, I went a little too far here. Type all that in your calculator and make sure you label properly. So 116 units squared. All right, so the longer ones, though, you have to use some trig. So looking back at your unit 7, when we did some right triangle trig, you have to do that here. So we have a hexagon, which is 6 sides, and we know the side length is 8, but we don't know the length of the apothem, and so we have to find that. So that 8 is split evenly as 4 and 4. And then if you draw that out, you can see that you have a right triangle. Okay. So we don't know, we're missing 2 sides of that right triangle, not just one. Every regular polygon can be divided into these isosceles triangles, and they're all the same. So a whole bunch of isosceles triangles. And if you notice, there are, in this shape, 6 isosceles triangles, and it's a hexagon. So there's the same number of triangles as there is sides. So really, if we can find the area of this triangle, we can find the area of the whole shape by just multiplying how many triangles there are. Okay, so that splits down the middle, and it creates this right triangle. Well, all of those split down the middle and create those triangles. And so there is double the number of triangles as there is sides in that case. And so we have this right triangle. And every circle, so the circle in the center here is 360 degrees. And if I split that by 12, by how many little pieces there are, let me fast forward here. So we have all of these triangles. So there's 12 of them because there's 6 sides, and they're all split into triangles, and those are all split into 2. Then we can take 360 and split it up evenly by those 12 triangles. And for this one, that gives you 30. Depending on the shape, that number may vary. And so 30 is your central angle. And we can now use that 30 to calculate, and your trig functions to calculate the missing side that we need. And so we have the opposite. We need the adjacent. And so we're finding this right here. And so we set that up. Opposite adjacent is tangent. So yeah, sorry. We know the side length is 8, and we know the number of sides. We're finding A. So we set that up with your trig ratio. So the tangent of 30 is equal to, oops, and again too far. Yes, please. Is equal to opposite, so 4 over A. Multiply both sides by A. And then divide, we'll divide off the tangent 30. So A tan 30 equals 4. Divide by tangent 30. And then type that in your calculator, 4 divided by tangent 30. And it should give us the apothem 6.93. All right, so then we're not really getting an exact answer because we rounded that. This is a 30, 60, 90, so you could put it in radical terms. I'm not going to be that worried about it. So you have all your dimensions now. We just need to plug in. So 1/2 times 6.93 times 8 times 6. Type that in your calculator and get your final area. Make sure you label it. So we're dealing with centimeters this time. So you have 166.32 Oh, and I put units. Should be centimeters squared. We know our units there. Okay, so same idea here. We have 360 times 12 because it's a hexagon again. It's always going to be double the number of sides. This time, though, we have our apothem, and instead we're finding our side length. And so we're going to do tangent of 30 is equal to x over opposite over adjacent. So multiply both sides by that 5 root 3. Just type that in your calculator, and you'll get 5. Keep in mind that that is this portion of the triangle. So the whole side length is 10. The apothem is 5 root 3. That was given. N is 6, also given. So we can type all of this in, plug all of this into our formula. So we have 1/2 times 5 root 3 times 10 times 6. This one we can leave as an exact answer. So 1/2 times 10 is 5, times 6 is 30, times 5 is 150. So 150 root 3. If you type all that in your calculator and give me a decimal, I'm not going to cry about it. So 150 root 3 inches squared would be the label on that, which I believe I forgot again on this one. And then last, I just wanted to remind you we can work backwards. We did a circle one. But if you have a rhombus and you know that the length of AC, so this diagonal is 8, and the area is 13, your rhombus formula is 1/2 d1 d2. Just plug in what you know and solve for what you don't. So sometimes you're solving for something on the left side instead of just solving for area. So 1/2, 8 is 4, divide that over, and D2 is whatever you get when you divide, so 3.25, and that's centimeters, okay, or whatever. All right, so that was it. Apologize for the mix-up on the first video. Good news is this one was a couple minutes shorter, so have a good night.